All right, 8.1, simplifying rational expressions. So again, when you have a fraction, you just ask the question, where do I have more and how many more? And I'm also going to deal with the numbers first. So if you just have this fraction 21 over 14, what is the common factor? And that's 7. So 7 goes into 21 3 times and 14 2 times. So I've just simplified that fraction. Now the letters. I have 3 x's on top, 2 on the bottom. Where do I have more? Up top. How many more? 1 more. Y. Where do I have more? On the bottom. How many more? 4 on the bottom, 1 on the top. That's 3 more on the bottom. And that's my answer. All right, number 2. What number goes into 50 and 35? That'd be 5, 10 times, and 7 times. X's. I have more x's on the bottom. How many more? 3 more. Y's. Well, I have 1 on top, 1 on the bottom. So those just cancel. And then Z's, I have more on top than the bottom, and it's 1 more. That's it. All right. Now, remember, the rule is factor, state the excluded values, then and only then cancel. So first I'm going to factor. Difference of squares. X plus 2, x minus 2. Trinomial. I need two numbers that multiply, give me 2 that differ by 1. Well, there's only one way to do it, 2 and 1. I want more negatives. And now, before I cancel, I state x cannot be positive 2 or negative 1. Positive 2 here would give me 0, and negative 1 here would give me 0. Now that I've stated my excluded values, I can cancel the x minus 2's. So where does that leave me? X plus 2 over x plus 1. And that's my answer. My simplified fraction and my excluded values, which did come first. Number 4, I'm going to factor top and bottom. So on the top, I need two numbers that multiply, give me 3. That's only one way to do that, 3 and 1. And they differ by 2. I want more negatives than positives. On the bottom, two numbers that multiply give me 12 that differ by 1. So that's going to be 3 and 4. I want more positives than negatives. Now don't be in a hurry to cancel those p minus 3's. I need this first state. P cannot be positive 3 or negative 4. Now I can cancel, and I'm left with p plus 1 over p plus 4. Okay, number 5, I'm going to take out the GCF, which for 15 and 12 would be 3. Also, I can take out 1x because they both have at least 1x. And that leaves me 5x minus 4. I can double check. 3 times 5 is 15. X times x is x squared. 3 times negative 4 is negative 12. Good to go. 6 and 18, I can take out a 6. I can also take out an x, just like on top. And then I divide and I get x minus 3. Now, I can reduce wherever I have possibility. But first off, before I do that, I need to say x cannot be 0, right here, and x can also not be 3. That would make this 0. A lot of people forget this one, but when you have an x that's not a binomial, no plus or minus, then you say x can't be 0. And now I'm going to reduce. So 3 and 6 both have a 3 in them. So that gives me 1 and 2. The x's just cancel. And I'm left with 5x minus 4 over x minus 3. All right, number 6. The top is an easy difference of squares, x plus 5, x minus 5. On the bottom, a little bit more work here. I have to do some guessing and checking. This has to be 3x and 1x. This is the only way to make 3. Now I need to find two numbers that are going to give me 10 that combine to differ by 13. Well, if I think 5 and 2, I'll put the 5 here and the 2 here, because that's going to give me 15 and 2. I want negative 13, so I need negative here and positive here. Okay. Now, again, before I can do any canceling, I need to say what my excluded values are. So x cannot be, I'll do the easy one first, 5. And the second one, 3x plus 2, if I set that equal to 0, it's going to be minus 2 divided by 3. So I'd move the 2 over and then divide by 3. Now, I can cancel these, which leaves me with x plus 5 over 3x plus 2, simplified. All right. Number 7. Whoops. Sorry about that. Number 7 is going to be a guess and check again. So this obviously has to be 2k and 1k. And I need to make 15, and they're going to differ by 1. So I'm going to put 3 here and 5 here, because that will give me 15, and that will give me 2 times 3 is 6, and 5 times 1 is 5. I want more negatives, so I want the 6 to be negative, and this to be positive. At the bottom, it's going to be simply k plus 3, k minus 3. Again, you're going to want to cancel those k minus 3's right away, but don't do that. You got to come down here and say k cannot be plus or minus 3. You can write them separately also. Now I can cancel this, leaving me 2k plus 5 on the top and k plus 3 on the bottom. Final answer. All right, number 8. On the top, all I can do is take out a 6. X minus 3. On the bottom, all I can do is take out a 6. Sorry, a 2. But that will give me x minus 3. Again, don't be in a hurry to cancel the x minus 3's. Okay? You need to say x cannot be 3. Now, cancel away, which leaves me 6 over 2. But remember, that simplifies to just 3. 3 over 1, or just 3. Right. Same thing here. Need to factor the top and bottom. I'm going to have some guessing and checking on both of them. So n and n. I need two numbers that give me 27 that differ by 6. Well, that's 9 and 3. I want more negatives, negative 6. On the bottom, I need two numbers that multiply to give me 6 that differ by 1. Well, that's 3 and 2. I want more positives. Now, here's a hint also. You're always going to have something that's going to cancel. So if I would have guessed negative 3 and positive 2, nothing would cancel, so that kind of helps. All right? Now, before I do anything, I must say what n cannot be, and that's negative 3 and positive 2. Cancel, leaving me n minus 9 over n minus 2. And remember, there's a tendency to want to cancel those n's right there. You can't do that because they're tied together as binomials. You can't cancel pieces. Okay? Up top here, the only way to get 2x is 2x times 1x. Okay? I need to make 35, which probably is going to be 7 and 5. This time, though, for the first time in this whole worksheet, it's going to add to 19. So I need 14 and 5. But since the negative 19 is negative, these are both negative. Negative times negative is positive, but they're going to add up to negative 19. And here, all I can do is take out a 2x, that's my GCF, and that leaves me x minus 7, which will cancel, but not yet, because I have to say x cannot be 0, and x cannot be 7. Now I can cancel, and I'm left with 2x minus 5 over 2x, but now I can cancel the 2's Oh, sorry, can't. Sorry, for a second my mind saw the 2 outside of parentheses. I cannot cancel the 2's or the x's because the 2x is connected to the 5 by subtraction, so I am finished. All right, number 11. Top is easy, difference of squares. That's going to be n plus 7, n minus 7. At the bottom, a little bit more work. Probably going to have an n plus 7 or n minus 7, hint, hint. So I need 2 numbers that give me 49 that add to 14. Well, that's going to be 7. Because 7 times 7 is 49, and 7 plus 7 is 14. They're both positive. Okay, because they have to both be positive. Now, before I do anything, I say n cannot be not plus or minus 7, just this time, just negative 7, because they're the same. All right, then I'm going to cancel those 2, which leaves me n minus 7 over n plus 7. That's it. Okay, up here, I have trouble with my marker for some reason, not sure why. Okay, I need 2 numbers that factor, multiply to give me 60 that differ by 7. Okay, so you have to think of different numbers like 10 times 6. Okay, they differ by 4. 12 and 5, that's our winner. Now I want more negatives than positives. So x minus 12 and x plus 5. And on the bottom, I have a difference of 2 squares, so x minus 12, x plus 12. Let's try this again. Different pen. That's better. And before I do anything, I must say x cannot be plus or minus 12. Now I can cancel, which leaves me x plus 5 over x plus 12. All right, now we're just factoring sum and different squares, so, and cubes. Sorry, this is supposed to be cubes. So I did the cube root of 8, cube root of x cubed, and the cube root of 5. I'm going to square the first, square the second, and then multiply them. And now I apply SOAP. So, same, opposite, always positive. Okay, same thing here. Cube root of 64, cube root of x cubed, cube root of 1. Square them. Square it, multiply it. And then same, opposite, always positive. Last, factor by grouping. Oops, so to include the negative. So I'm going to take out an x squared and get x plus 5. I'm going to cheat and write x plus 5 right here. And I'm going to ask myself, what do I need to divide this by to get x plus 5? And that'd be negative 9. I'm going to hook those up. X squared minus 9 times x plus 5. But then here I have a difference of squares. So that's going to be x plus 3, x minus 3, and x plus 5. Final answer. Grouping again, I'm going to take out just x squared. That's going to give me 3x minus 2. I'm going to cheat and write 3x minus 2 right here. And then what do I need to divide this by to get positive 3, negative 4? I can check 8 divided by negative 4 is negative 2. So it's x squared minus 4 times 3x minus 2. But again, difference of squares, x plus 2, x minus 2, 3x minus 2. And that's it.